Have you ever held a mechanical watch, listened to its subtle tick, and wondered about the intricate world hidden beneath its dial? It's more than just a time-telling device, it's a miniature universe of gears, springs, and levers, all working in perfect harmony without a single battery. Today, we're diving deep into the heart of these incredible machines. We're going to count down the 5 essential elements that transform a good mechanical watch into something truly magnificent, the unsung heroes that make horology an art form. Get ready to discover the magic inside your watch. Kicking off our countdown at number 5 is robustness and durability. What good is a beautiful, intricate machine if it can't withstand the rigors of daily life? A truly great mechanical watch isn't just precise, it's also built like a tank. This means using resilient materials for the case, like stainless steel or titanium, and incorporating clever designs to protect the delicate movement inside from shocks, moisture, and magnetic fields. Think of it as the watch's armor, ensuring it keeps ticking accurately for generations. Consider, for instance, water resistance, a key aspect of durability. This isn't just about swimming, it's about protecting the movement from humidity, splashes, or even rain. Gaskets and seals are crucial components, usually made of rubber or synthetic materials, carefully fitted in the crown, caseback, and crystal to prevent water ingress. Another invisible enemy is magnetism, which can throw off a watch's accuracy. Anti-magnetic materials, like silicon balance springs, are increasingly used to shield the movement. These unseen protections are fundamental to a watch's long-term performance. Coming in at number 4 is movement finishing. This is where watchmaking transcends pure engineering and becomes true art. Movement finishing refers to the decorative and functional treatments applied to the internal components of a watch, even those you rarely see. Techniques like cotes de Genève, beautiful parallel stripes, or perlage, a pattern of tiny, overlapping circles, aren't just for show. They also smooth surfaces, reduce friction, and trap microscopic dust particles, contributing to the watch's longevity and performance while looking absolutely stunning. Beyond the visible patterns, finishing also includes anglage, which is the hand beveling of sharp edges, usually polished to a mirror shine. This isn't just for beauty, it removes microscopic burrs that could flake off and interfere with the movement. Even tiny screws are often heat-treated to a vibrant blue color, known as blued screws, not just for aesthetic appeal but to increase their hardness and corrosion resistance. Every minute detail, whether seen or unseen, speaks volumes about the craftsmanship and dedication poured into a high-quality mechanical watch. Movement finishing is often a labor-intensive process, demanding immense skill and patience. While some basic finishing can be done by machine, the truly exquisite examples, the sharp, gleaming anglage or the perfectly uniform perlage, are almost always executed by hand. This human touch is what separates mass-produced movements from haute horlogerie, or high watchmaking. It's a testament to the fact that even in an age of automation, the artistry and precision of the human hand remain irreplaceable in creating something truly exceptional. At number 3, we have power reserve. This refers to the length of time a mechanical watch will continue to run after being fully wound, without any further winding or wrist movement. In simpler terms, it's how long your watch can sleep before needing to be rewound. Early mechanical watches often had power reserves of around 30 to 40 hours. Today, thanks to innovations in mainspring materials and movement efficiency, many watches boast 70, 80, or even several hundred hours of power reserve. This convenience is a huge benefit for wearers who rotate between different watches. Think of the power reserve like the fuel tank in your car. A larger tank means you can drive further without refueling. In a watch, the mainspring is the fuel tank. It's a long, coiled strip of metal that stores the energy when wound. As it slowly unwinds, it releases this energy to power the entire movement. Innovations like multiple mainspring barrels, essentially adding more fuel tanks, or using advanced, high-density mainspring alloys have dramatically increased power reserves. A longer power reserve means less hassle and more reliable timekeeping, especially if you don't wear your watch every day. Many mechanical watches also feature automatic winding, where a semicircular weight called a rotor spins with the motion of your wrist, automatically winding the mainspring. This means as long as you wear the watch regularly, it will continue to wind itself, extending its power reserve indefinitely. When combined with an already impressive base power reserve, it creates a truly set-it-and-forget-it experience. This blend of clever engineering and practical convenience makes a strong power reserve an indispensable element of a great mechanical watch. Sliding into our number 2 spot are complications. In watchmaking, a complication is any function a mechanical watch performs beyond simply telling hours, minutes, and seconds. These can range from practical additions like a date display to incredibly intricate mechanisms like a perpetual calendar or a tourbillon. Complications showcase the pinnacle of watchmaking skill, demonstrating mastery over miniature engineering and precision assembly. They add utility, artistry, and a fascinating depth to the mechanical watch experience. Let's take the perpetual calendar as an example. This isn't just a date display, it's a mechanism that correctly accounts for the different lengths of months and even leap years, meaning it won't need manual adjustment until the year 2100. Imagine the hundreds of tiny components, springs, and levers that must interact perfectly to achieve this. It's an astronomical calendar condensed into a space no bigger than your thumbnail, a true testament to human ingenuity and the enduring pursuit of mechanical perfection. Then there's the tourbillon, invented by Abraham Louis Breguet in 1801. Originally designed to counteract the effects of gravity on a watch's accuracy, particularly in pocket watches that stayed in one orientation, it's a rotating cage that houses the escapement and balance wheel. While its practical benefits are debated in modern wristwatches, its hypnotic motion and immense complexity make it a breathtaking display of mechanical art. A tourbillon watch often requires hundreds of hours of work and extreme precision to build. Other complications include chronographs, stopwatches, minute repeaters, which chime the time on demand, and even equation of time displays, showing the difference between solar time and standard time. Each one represents a unique challenge for the watchmaker and adds a layer of depth and fascination to the watch. They are miniature mechanical computers, solving complex problems with purely physical means. The presence and execution of such complications are undeniable indicators of a truly great mechanical watch. And now, for our number 1 element that makes a mechanical watch truly great, the balance wheel and escapement. This dynamic duo is the very heart of the watch, responsible for its accuracy and consistent timekeeping. Without them, a mechanical watch would simply unwind uncontrollably in seconds. The balance wheel, often a delicate ring, oscillates back and forth, while the escapement acts like a tiny gatekeeper, releasing stored energy from the mainspring in precise, measured pulses to keep the balance wheel swinging. This rhythmic dance is what produces that characteristic ticking sound. The balance wheel and its attached hairspring, a tiny, incredibly thin coiled spring, form what's called the oscillator. The hairspring ensures the balance wheel swings at a consistent frequency, typically 28,800 vibrations per hour, or 4 Hz. The escapement, consisting of the escape wheel and pallet fork, is the genius part that translates the continuous force from the mainspring into these regular ticks. It locks and unlocks, giving the balance wheel a tiny push with each oscillation. This precise regulation is absolutely fundamental to a watch's ability to keep accurate time. Innovations in this area are constantly pushing the boundaries of accuracy. Modern materials like silicon are revolutionizing hairsprings and escapement components, making them immune to magnetism, highly stable across temperature changes, and resistant to wear. These advancements allow watches to maintain incredible precision, often losing or gaining only a few seconds per day. The balance wheel and escapement are not just parts, they are the rhythmic soul of the mechanical watch, and their perfect orchestration is why they deserve our top spot. So there you have it, our top 5 elements that make a mechanical watch truly great. From the robust armor protecting its delicate heart, to the intricate artistry of its finishing, the convenience of a long power reserve, the breathtaking complexity of its complications, and finally, the ultimate precision governed by its balance wheel and escapement. Each element plays a vital role, transforming a simple time-telling device into a wearable masterpiece of engineering, history, and art. It's a testament to human ingenuity and a reminder of the beauty found in finely crafted machines. Which element do you think is most important? Let us know in the comments below.